So in the previous lectures, like Z transform properties and all we covered. So first, in next inverse Z transform calculation, there are 4 methods in inverse Z transform calculation. And also one more point, like initial value theorem and final value theorem defined for Laplace transform. Same theorems are there for Z transform also. So if you see the initial value theorem in Z domain, the statement is that if initial value theorem, if x of n Z transform is x of z, then the initial value theorem states that x of 0 initial value is limit z tends to infinity x of z. Okay, the proof is also very simple here. Let us see the proof for only initial value theorem. For final value theorem, simply the statement I'll give. So let us take the standard Z transform formula here. Summation n equal to minus infinity to infinity x of n into z power minus n. Okay. Apply limit z tends to infinity on both the sides. X of z equal to limit z tends to infinity, and this total term as it is we will write. Okay, let us write this total term as it is. And then limit z tends to infinity. We can write this as x of 0, because over this entire duration n equal to 0 term will also be included. N equal to minus infinity to infinity, n not equal to 0, n is not equal to 0, x of n into z power minus n. Okay. So now from this again, limit z tends to infinity x of 0 plus limit z tends to infinity for remaining all the terms. N equal to minus infinity to infinity x of n into z power minus n. So this is nothing but x of 0, whereas that is 0. So this is x of 0, because infinity power minus n means 1 by infinity, its value is 0, hence proved. So this is a statement of initial value theorem. Similarly, we also have final value theorem. Okay. So let us see the final value theorem statement also now. Next, final value theorem. Final value theorem. So same as that, if x of n z transform is x of z, then final value theorem states that x of infinity, now final value means, so it is equal to limit z tends to 1 z minus 1 into x of z. So same as that, we can prove this also. So please go through the proof. In any standard textbook, proof is there. A simple steps, easily you can understand the proof also. Let us see one simple example, how to use these theorems. Just apply this theorem on simple problem. Okay, let's find out the problem. Let us see problem. Find out the initial value. Find initial and final values for the following function. For the following function, x of z equal to z square by z minus 1 into z minus 0.2. Okay, let us see the proof now. I mean solution. X of 0, limit z tends to infinity. X of z we have to write, right? So limit z tends to infinity, z square by, please multiply whenever factors are there, try to multiply it. So if you multiply it with 0.2 z minus z plus 0.2, directly I have written multiplied expression. Next, limit z tends to infinity, z square by z square minus 1.2 z plus 0.2. Okay, next limit. So whatever highest power is there in the denominator, take the highest power as common term. If z cube is there, you take z cube as a common term, because we want z terms only in the denominator. 0.2 by z square this is. Z square will get cancelled. If you apply limit 1.2 by infinity plus 0.2 by infinity, these two values are zeros. So final value, initial value is 1. So same as that, we can also find final value x of infinity. How to find it? Limit z tends to 1, z minus 1 into x of z. So if you apply this, z tends to 1, z minus 1 into what is x of z? Z square by z minus 1 into z minus 0.2. Z will get cancelled. 1 you substitute, 1 by 1 minus 0.2. It will be around 1.25. Like this, we have to use these theorems to solve the problems. Okay. Try to get infinity in the denominator, then easily you will get the constant value. Whether it may be 0 may be there, infinity may be there. Okay, whatever may be the constant here. But proper arrangement should be there first. Okay, whether cancellation is possible or not, that you need to check out. Okay, this is about initial and final value theorems related to Z transform concept. So next important concept is about inverse Z transform. Till now I have not introduced the concept of inverse Z transform using the standard formula. Actually, to calculate inverse Z transform, we are having totally 4 methods. One is power series expansion. Power series expansion, which is also known as long division method. Long division method. And the second one is partial fraction method. Then third one is contour integration. Contour integration or residue method. Convolution method. Okay, these are the 4 methods for calculating inverse Z transform. Just a basic example I'll take to explain all these 4 methods. I mean simple expression in Z domain. Again, in digital signal processing subject, same thing will be there. There also calculation of inverse Z transform, system related functions. More you are going to study about Z transform. So related to signals and system, the basic generalized function I will take in Z terms, and we'll let us see how to use this. You implement this particular method to find inverse Z transform function, that is x of n. Okay, with one example each method. So these are the 4 methods: contour integration, residue method, and all. Okay. So first put the heading power series expansion method. Power series expansion. So here problem. Find inverse Z transform for x following function x of z equal to z by 2z square minus 3z plus 1 using power series expansion method for mod z less than minimum of poles, mod z greater than maximum of poles, 1 is given. In 2 cases, inverse will be different. Okay. So in power series expansion, first, what is the first? Mod z is less than 1 by 2 is given. So remember here, this is having 2 poles, 1 comma 1 by 2. These are the 2 poles. Mod z is less than minimum of poles means x of n is going to be anti-causal sequence. Anti-causal sequence means in x of z, z should be having a positive powers of z. Positive powers will be there for z. Okay. So for that reason, the name itself is suggesting long division method means we have to divide the given z domain function with the denominator z by 2z square minus 3z plus 1 means 1 minus 3z plus 2z square. Why I am taking 1 as a first in the divisor means I want, this is z, I want quotient as positive powers of z, because first case ROC is less than pole. Less than pole means x of z should be having a positive powers. It should be a series of positive powers of z. Okay. Why? Because if you see the summation x of n into z power minus n, this is a formula, right? X n equal to minus infinity to infinity. When n is negative, then only we will get positive powers. Okay. N is negative means negative indexes indicates left-sided sequence, anti-causal sequence. So that's why here we have to divide the function with the constant by taking constant as first. So then what I have to select quotient 1. Now multiply this total divisor with the term z. Z minus 3z square plus 2z cube. Okay. Minus plus minus subtraction. 3z square minus 2z cube. Next, 3z square has to get cancelled. So easily we can select the 3z square. Now multiply this total term. 3z square minus 9z cube plus 6z power 4. Now again cancellation, minus plus minus. 9 minus 2 is 7z cube minus 6z power 4 plus 7z cube. So multiply with the 7z cube. Minus 21 z power 4 plus 14 z power 5. Minus plus minus 21 minus 16, 15 z power 4 minus 14 z power 5. So next term will be obviously 15 z power 4 plus so on. Okay. So 15 z power 4 will be there here, minus whatever terms you get, you can write. So this is repeating. This is repeating. So finally we write x of z as z plus 3z square plus 7z cube, like that up to 3-4 terms, 4 to 5 terms you can stop and you can put this symbol, so on. From this inverse z transform directly we write it. This is a left-sided sequence. So initially n equal to 0 index will be 0. No constant term is there. Now when n equal to minus 1, z power 1 coefficient is 1. N equal to minus 2, z square coefficient 3. N equal to minus 3, z cube coefficient. N equal to minus 4, z power 4 coefficient. Like that it is repeating this sequences. Okay, negative sided sequence, anti-causal sequence. This is the case when ROC is less than its pole, minimum of poles. Okay. Now let us see for the second case when mod z is greater than 1. Okay. Second case, mod z greater than 1 means greater than maximum of poles means causal sequence. Causal sequence means x of z must be positive powers of z. So for that reason, 2z square minus 3z plus 1 as it is z divided with. So here z term has to get cancelled. So first you have to here negative powers I want. Z should be negative powers. Causal sequence means, I'm sorry, here negative powers should be there. N equal to positive, z power minus n means n positive means negative powers of z will be there. Anti-causal means positive powers of z. Now tell me what is the first term that I have to select here. Suppose if I select half into z inverse, multiply 2z square with this term half z inverse, what you will get? Z. So like this, first term has to get cancelled. Like that you have to select. Okay. 2z square into half z power minus 1 is plus z, minus 3 by 2 plus half z power minus 1. Multiply this total divisor with this term quotient. Okay. Minus plus minus 3 by 2 minus 1 by 2 z power minus 1. Now I want a term here such that when I multiply it with 2z square, I have to get 3 by 2. So 3 by 4 z power minus 2. Multiply 2z square with 3 by 4 z power minus 2. You will get it as 3 by 2. Next, minus 3z into 3 by 4 z power minus 2. Minus 9 by 4 z power minus 1 plus 3 by 4 z power minus 2. Now again subtraction. Minus plus minus 9 by 4 minus 1 by 2. 9 by 4 minus 1 by 2, you will get it as 7 by 4, I think. Z inverse minus 3 by 4 z power minus 2 plus 7 by 8 z power minus 3. Here 7 by 4 is there. 7 by 8 into 2z square. You get it as 7 by 4 z inverse. Next term minus 21 by 8 z power minus 2 plus 7 by 8 z power minus 3, so on. Like this it is repeating. So finally we write x of z as one more term you can take. If you want one more term also you can take minus plus minus. Like this it is repeating. So half into z power minus 1 plus one more term you can take here plus 7 by 8. From this, what is x of n? Constant term is not there, coefficient we have to take it as 0. Positive sided sequence, z power minus 1 coefficient is 1, n equal to 1, n equal to 2, n equal to 3, so on. This is the inverse Z transform. This is a method for power series expansion method or long division method to find inverse Z transform of a given sequence. Okay. So like this, for any given function, depending on ROC, whether positive powers of Z we want, negative powers of Z, by observing that, we have to do the division process, then writing the coefficients of Z powers. That's it. Okay. This is about long division method. So next, let us go for next method, partial fraction method. Okay. Put the heading, partial fractions method. So this already we have been seeing this partial fraction method from Fourier transform onwards. Okay. So let us see one example for this also. Write down problem. Using partial fraction. Using partial fraction. Find out the inverse Z transform. Find out the inverse Z transform for x of z equal to 1 divided by 1 minus 1.5 into z inverse plus 0.5 into z power minus 2. Okay. And first bit is given as ROC mod z greater than 1. ROC mod z less than minimum of poles. And third one, mod z in between two poles. Okay. 0.5 less than mod z less than 1. Now let us see the problem. First we need to find the partial fractions, obviously. So first write the function in terms of z square terms. I mean positive powers of z. 1.5 by z square. Now if you take z square in the numerator, z square minus 1.5 z plus 0.5, right? So now try to write the function first x of z by z, then z by, find the factors. Obviously two factors will be there. Just by observing the poles itself, you can write the factors. Okay. So this we can write it as, always try to find partial fractions for x of z by z. Okay. Now to finding the constant, already I have explained the shortcut method. To find constant here, whatever denominator is there, equate it to 0. Then what about z1? Where you have to substitute this one in this function. 1 by 1 minus 0.5. Z minus 1 we should not consider. The corresponding constant itself we are trying to find. So neglect z minus 1, and in remaining expression you substitute the denominator factor z equal to 1, which value is 2. Similarly, B also, if you find z minus 0.5 equal to 0, then what is that? 0.5. Okay. So z equal to 0.5, you substitute here again. 0.5 by 0.5 minus 1, you will get it as minus 1. Okay. So after finding the partial fraction, simply substitution. Substituting in the expression. So now x of z by z equal to 2 by z minus 1 minus point minus 1 is 1 we got the b value. So 1 by z minus 0.5. Okay. So now tell me what is x of z? 2 into z by z minus 1 minus z by z minus 0.5. So first bit already we know that we are having two sides, a power n into u of n, z by z minus a, mod z greater than a, or we can also write it as 1 by 1 minus a z inverse. Both are same. Next we also have minus a power n into u of minus n minus 1, same z transform is there. But what is ROC? Less than its pole. Okay. So now take the given ROCs and whether we want to choose causal sequence or non-causal sequence, whether ROC is greater than pole or less than pole, that we need to observe. And based on that, we have to select inverse Z transform. Okay. This is causal sequence, anti-causal sequence for this corresponding Z transform. Now, first mod Z is greater than 1, maximum of poles. So all causal sequences we have to select by applying IZT on equation 1, IZT on 1, x of n equal to 2 into, in place of here 1 is there, 2 into 1 power n u of n minus, next causal sequence is 0.5 whole power n u of n. This is for the first case, ROC. Similarly, mod z we have less than 0.5, means all non-causal sequences, anti-causal, I'm sorry, means this one, anti-causal sequences means. Then from this equation 1 only, what is the inverse Z transform? Minus a power n, 2 is there, 2 as it is I have written, but minus a power n, so minus a 1 power n u of minus n minus 1, already minus is there, plus a power n 0.5 minus n minus 1, like this. And third case what is the ROC? 0.5 less than, mod z less than 1. So this is having mod z greater than 0.5 is the mod z less than 1. So this corresponding anti-causal, this corresponding, sorry, this is corresponding to causal, greater than 0.5 is given, right? So this corresponding to causal we have to select, here anti-causal I have to select. So from same equation, equation 1, x of n equal to mod z is less than 1 is there. So this corresponding pair inverse is anti-causal. So minus 2 into 1 power n is 1 only, and mod z greater than 0.5 means దీనికి causal తీసుకోవాలి మనం. So we have to take a causal sequence for this. Minus 0.5 power n u of n. Okay, this is a Z transform. These are the corresponding inverse Z transform techniques. Okay. So remaining two techniques we will cover in next video lecture. Okay.